So today's demo actually is not so much an ExoGENI demo. It's more of a demonstration of support for kind of soup to nuts type of experimenter tool chain for creating experiments, collecting your data, storing your data, observing the results, analyzing them, and so on. And that's really the kind of demos I would like to do from now on. I don't, I've done 3 years worth of demos of what our control framework can do, but it's time to actually show what can be done with it rather than just doing these demos. So first, actually, can you back up one slide? So this demo is a result of work of a number of people, and so I just wanted to acknowledge everyone who was named on this slide. I very much would like to acknowledge Mike Zink and his students, Dilip and Kong, who's made a lot of this possible. So ExoGENI. ExoGENI is going to have, whoa, okay. Lost text? Okay. Well, ExoGENI rack, IBM hardware. In ExoGENI, we're putting an emphasis on using as much of off-the-shelf software as possible. So the provisioning engine for ExoGENI underneath the Orca control framework consists of two parts. The virtual machines are provisioned using OpenStack. We're currently on Diablo version and moving to SX at fastest possible speed. And the bare metal node provisioning is supported by AXCAT. Which are two separate open source projects outside of GENI community, but we're trying to take advantage of them. Monitoring within GENI racks is done using Nagios, and we've built up some conduits to supply data from Nagios into the GMOC data collection service. Each rack consists of typically of 10 worker nodes plus a head node, IBM M4 hardware with dual socket, 8-core CPUs, 48 gigabytes of RAM, and two 10 gigabit per second adapters from Chelsea, actually a dual port Chelsea 10 gig adapter. The OpenFlow switch behind the rack is a 10 gigabit and a 40 is a switch with 10 gigabit and 40 gigabit ports from BNT/IBM, and we also obviously have a management switch for internet. Commodity internet access into the rack resources. Each rack also has a 6 terabyte storage, iSCSI storage system connected to its management network for supporting kind of large storage needs on each rack. The important thing is that if you want to learn more about what ExoGENI hardware is like or how to use it, the URL actually did get preserved in the presentation. It's http://wiki.exogeni.net. So next slide. So as far as status, we have two racks that essentially the GPO is paid for and have been deployed, one at RENCI, one at BBN. We have two that we are about to order that will go to Florida International University and University of Houston. And we have a partner rack in Australia that Max Ott has graciously paid for, and we just finished setting it up. The racks that we've deployed on the continental United States, we can actually connect between them. The rack in Australia is connected to Internet too, so Max has solved all the connectivity issues on his end. We have not solved connectivity issues on our end in order to allow his rack to be connected to the others, but we will address that. And of course, the racks are connected via a variety of regional and national providers. Next slide. So the big focus of ExoGENI is isolation, performance isolation. So it comes in a variety of flavors, but one of the things we do is when it comes to providing virtual machines, which is what is the most typical computational sliver within ExoGENI, we don't oversubscribe the cores. So when we tell you you've got so many cores in a virtual machine, that's really the cores you're getting. We work very hard on providing the performance isolation at the VLANs whenever possible. That's not always possible right now, but we will continue working on it so that you can have repeatable experiments, that both involve just resources from one rack or perhaps from multiple racks. This is the So what we're going to do now is do the actual demo, a prototypical experiment on ExoGENI that will show this entire workflow where we define an experiment, provision the resources, launch experiment, and collect the data, and observe and analyze. And it's going to be very simple. We didn't really want to get overly complicated. The idea is not to drown out the details of how it's done, but what's really being achieved, which is this kind of end-to-end support for experiment needs within ExoGENI. So I will begin on this side by defining a very simple slice topology. It's a triangle. Aren't we? I'm going to be able to see this. So what we're going to do is send traffic between these two nodes at nodes A and C, wherever they happen to be, A and C, either directly or through the other node. And what we'll do is make sure that this node is far away. We're going to put it, if I do it right. Can you walk over and tell me? Because I can't see. Is this the RENC rack? Okay. So I'm going to put this node at RENC rack, and I'm going to put the other two nodes at the BBN rack. As I said, we're doing something. Huh? It's already BBN. It's already BBN. Okay, it's already done. And you know, as you see, the nodes are connected with each other. In each link, on each link, the interfaces of these nodes, we've assigned pre-assigned IP addresses. So, and these addresses are within the data plane of the slice, independent of the commodity internet, you know, under experimenter's control. And then there's a fairly sophisticated Postboot script executed by each node, which sets up the experiment and launches the experiment and arranges for data collection. So there's very minimal work needs to be done after the provisioning step begins. Most of the steps are fully automated through a variety of scripts and tools. All right. So all I'm going to do is say submit. And the system will start working on actually provisioning the resources. Well, as in any good cooking show, and I'm stealing a joke, I apologize. As in any good cooking shows, here were the ingredients, and we just mixed them together. And here's the ready product that we're going to show you. We don't really have the time to wait for the slice to come up. So, you know, when it does come up, it will look something like this. We already have a slice ready. It does look a little bit like a circle. That's just because of the graph layout works this way. But if you notice, you know, this is the node that was in the RENC rack, and these two nodes are at BBN racks, in the BBN rack. And these are all the network providers we went through and requested either statically allocated VLANs or dynamic. Actually, we don't have any more dynamic allocated VLANs. Actually, no, we do in Ben. So to create a layer 2 connection from one rack to the other, actually two of them, one way or the other. And so what we're going to see is we're going to initially compare latency on this link versus routing through around this ring, right? Now I'm gonna pass on the baton to Mike to explain how the rest of the experiment works.
So as in any good cooking show, I'm now taking the cake out of the oven. It's already done, and I put the icing on the cake, so to speak, now. So let's talk about a little bit to set this in context with an experiment. So Ilya with ExoGENI and the wonderful tools his team has put on top of it has now set up a slice, right? So we have a set of resources we can use now for our experiment. So what's also happening in the background, he mentioned the Postboot scripts. And what we have done also in addition is we have now created an image for ExoGENI that comes up with pretty much all the tools I'm mentioning here. So we are really providing you with a lot of tools to start experiments, run experiments, measure experiments, and analyze your experiments. So what you see on this graph here, on top you have iReal. That's actually, you could also say iReal/portal. Max, I hope that's okay with you. This is our measurement portal where we will run everything under. So you have kind of one point to go to for your experiments. And then you have Flukes and ExoGENI to acquire your resources. You have OMF, the Orbit Measurement Framework, to orchestrate your measurement, to orchestrate your experiment. And then what you have, you provide your resources, and then when you launch your experiment, you're using, again, OML, the Orbit Measurement Library, which gives you a way to orchestrate your experiment. The library gives you a way to put certain hooks into your experiment to perform your measurements. And then what you see on top of it is iRods. That's the integrated rules-oriented database, data storage system. That is a storage system we have built in GEMI, in one of the measurement projects, to allow you to store your measurement data and then remotely access it, analyze it, restore it back, and so on. So this is kind of, oops, I forgot to go through the animation. These are the different steps here you go through in all the tools we are using. And so I want to go to the next step and set this a little bit into context. So what you see here is from your side on the top left corner is actually the ExoGENI resources, right? We have node A and B, node A and C in RANC and node B and BBN. Did I do this the right way or did we do this the other way around? Okay, cool, got it right. Through the virtual machine image we're bringing up here with us already resource controllers and measurement libraries here from OMF and OML in there. So this is automatically coming up. We instrument this, we orchestrate that. And you see here the two paths we're going with this. And then what we have in addition, we have this right now at UMass, is a persistent server where we run an OML server, the aggregate manager, XMPP server for the messaging between different OMF entities, iRods and iReal. So this is all in the persistent space. This is going to be existing pretty much constantly. And then we also have a user workspace, which is actually something we created in collaboration with Genioran from the GPO, a virtual machine you can run in VirtualBox that actually allows you as a user to get access to all these tools. We have pre-installed that to run experiments with the experiment controller, to do visualization, and to use an iRods client to get your data in and out of the distributed data storage here. So I just have a small list of the tools we're using here just to, bring this back and remind of all the tools we're using. I think I mentioned them all already. Before we get started, one thing I want to mention is what is really important here is that we actually on making the first steps of really being able to do truly repeatable experiments. If the network isolation is completely solved, what you should be able to do is if I create an experiment, I make all the data about this experiment available to you. For example, the RDF file you use to set up your ExoGENI resources, the experiment descriptor to run OMF and OML, to store the data all in one space. You should go and be able to take all this data and rerun this experiment and get most likely pretty much the same result, more or less. So this is really something with the isolation we have, we can create through the ExoGENI regs with documentation and making everything public. You should be able to run experiments over and over again in exactly the same settings, so to speak. Okay, so what we're going to show now is we're going to Nikta's iReal portal here, and Dilip is going to start a new experiment. Come up with a good name. Okay. So we're testing a plenary. And so what we're doing here is the slice is already up, so we have the resources on the ExoGENI regs already running. This whole substrate I'm showing here, the top left, is up and running, and now we are orchestrating our experiment. We have already, with respect to time, defined an experiment description. We have an experiment script. The OML and OMF tools are already running on the different entities, also in the portal here. Dilip just has to select a couple nodes and set a couple parameters right here. Specifying the sink and the source nodes. It's kind of hard to read. Okay, and that's all you do. So you fire your experiment. It goes into a queue, and then we wait for the scheduler to fire. This might take a moment, so this gives us some time to mention things we forgot. Ilya, anything you want to mention?
ExoGENI racks and their design. So as I said, our partner in this, industrial partner in this is IBM. We have started conversations with them about creating community pricing for the configuration that we're using. So if you're interested in getting one and have a little bit of money lying around, come talk to me and we can make something happen.
Okay. While we're waiting for the experiment, can you refresh, Dilip? While we were waiting for the experiment to start, I also want to say, because that's, you know, we will show you the results in a second when it's done. But in the meantime, I want to use the opportunity to thank all the people who helped with this demo. It's been, you know, I think it's been 3 years actually since we're working together on different projects here. It's been really a pleasure to work with Ilya and his team at Renzi. They are, I don't know when those guys sleep, but you know, every time you send them an email, they fix your problem in like, you know, 5 minutes later or something. It's Max, you know, has done incredible stuff. He actually was kind enough to send Christoph to us for a week last week to help, you know, getting things ready and integrating things. And you know, there was a lot of support and a lot of things going on. And that was truly great in making all the integration work doing here. And you know, as you have it in demos, now it's kind of a little bit of a hiccup, and it takes a moment to get this into the queue. And have the scheduler fire. I think we forgot to give the scheduler its coffee this morning, so I think this is one of the problems we're dealing with here. While you wait for this, Dilip, why don't you go to one of the experiments we had run a little bit earlier this morning and just show. So, you know, since we're good cooks, we also have prepared the final results here. So as you can see, you see here that you see the results of the ping here. It's a little bit hard to read because the scales are a little bit different, but you see the direct link, which you see on top, is only, is it even a millisecond? I don't know. It's under a millisecond or something. There's half a millisecond is what they're telling me. And so this is between node A and node C here. And then when you go to the lower graph, you see it's roughly 40 milliseconds, a little bit lower, between node A and node C again, but via node B. So it's taking quite a bit longer. And so you can see here how, you know, you have all your information together. You just go to this portal, you take your experiment script, you run the experiment, you get the information. I get a thumbs up from Kong here in the background. You might want to go back and see if it has fired. No. Kong says it's running. Can you reload it? Okay. Sometimes you just have to hit the reload button. Sorry for the slight delay here. But I see, thanks to Mark's ginormic watch, we have an hour, minute 16 to get finished with that. So, so this is just now, you know, this is the boring part. There's a lot of bits doing hard work on computers right now, so the experiment is running in the background. And, you know, in roughly about a minute or so is what we're running this for. We should be done. You know, while this is running, why don't we take the opportunity and why don't we take the time and give you the opportunity to ask a couple questions, if there's any questions.
Thank you. I was just curious when you showed the map with where you have racks. I saw one rack on the top of Alaska. Can you explain that?
I'll let Ilya answer this question.
Yes, so the racks in Alaska, yes, we have another set of partner racks set up by our friends at the University of Alaska Fairbanks. We're still kind of bringing them fully online with respect to the latest code base. They are operational and they're using them on their own, but what we want to do is kind of make them a resource just like all the other racks. So that's a process that's ongoing and shouldn't actually take that long to complete.
Maybe there's more questions.
Is it still running? So the experiment description, I think, set up the experiment to run for how long? 1 minute. Okay, so that's for 1 minute to take in data through in the slice, measuring both throughput and latency across those two links. So we still says running, I think. The important takeaway here is that there is this workspace for the experimenter to store the entire set of data associated with their experiment. The request that they created to create the topology that was needed, the associated metafiles, the scripts that run the experiment, et cetera, et cetera. And all of this is stored the data associated with it is stored along with the experiment description and can be retrieved later for, in order to be repeated and so on. Is it done? Still running. And then you can graphically inspect the output of the experiment by looking at the data that was collected. So.
Okay. Good. No, I think we're out of time, so thank you very much. We're going to be around for the remainder of the day, so if you have any further questions, please come by and see us.